So now, as I had explained you in the previous class itself, we are going to understand what is the final value theorem, convolution property, time reversal, multiplication by a ramp, initial value theorem. These things we have studied already. Okay, initial value theorem provides us the initial value of the given sequence before applying the signal. Okay, initial value is at n is equal to 0. What is Z transform? Okay, next is final value. In final value theorem, we are going to find out what is the final value of a particular sequence. Say, if some sequence is given like this, x of n is equal to 1, 2, minus 1, plus 3, something like this. Okay. Is it possible for us to determine what is the final value, that is this final value of the sequence? Is it possible for us to determine what is the final value of this sequence by knowing the Z transform of this sequence? Okay, that is given by this final value theorem. It will tell us how to find out final value if we know Z transform of a given sequence. So it is nothing but the limit x of n, limit n tends to infinity x of n. If your n is going to infinity, it will be called as x of infinity. So x of infinity will be given by limit z tends to 1, z minus 1, x of z. So this x of z is z transform of x of n. So if we know the z transform, then multiply it by z minus 1 and apply the limits as z tends to 1. It will give us the final value of the given sequence. Okay. And where it is used? It is used to find out the steady state value of the given signal without even knowing x of n. So that is what explained here. So steady state value andre eno nimma control system alli odirtira. So this is your rise time and it will oscillate, and what is this value? What is the magnitude of this? This is called as steady state value or x of infinity. Okay, this is continuous time. For discrete time also you might get samples like this. Okay, so this is this steady state value. What is the magnitude of the steady state value? That is given by this final value theorem. Proof of this we'll discuss later. Okay, only a statement I am giving. As n tends to infinity, limit z tends to 1, z minus 1, x of z. Using this we can find out the steady state value of a given sequence, or x of infinity we can find out. Next, difference in time property. It is nothing but shift property only, but given in different manner. Okay, so let me consider the property here itself. You can see x of n minus x of n minus 1 will give us z transform 1 minus z inverse x of z. So this is nothing but x of n minus n naught. Z transform of this is z to the power minus n naught x of z, correct? This we have seen in the time shifting property. So for that x of z, say this is x of z. First term will yield us x of z. Second term will yield us minus z minus n naught x of z. So if I take x of z as common, what I am left with? 1 minus z to the power minus n naught. I can substitute any value right here. N naught is equal to 1 here. n is equal to 1. It might be plus 1 or minus 1. It is minus 1 here. That's why we are getting minus n. If at all it is a plus 1, we might have what? A plus z to the power plus n naught. Here it is a minus sign. If it was plus, then we might have used plus over here. So this is a very simple property, difference in time. Okay. Is it clear? Ritik, are you there? Ashok? Yogesh? I hope I am audible to all. Pavana? Nisarga?
Yes, sir.
Yes, you are there, right? Okay. So is that understandable?
Yes, sir.
So this is the difference equation. Now let me know if at all I give a sequence like x of n plus 1 plus x of n minus 1. For this, what is the z transform? You can send me your answers, okay, in the message box. X of n plus 1 plus x of n minus 1. What is the answer? If anyone willing to tell the answer, those who have computed, by looking at the signal itself, you can tell. Yes, Manoj. Nobody knows? If x of n provides you x of z, x of n minus n naught provides you z to the power minus n naught x of z. I am asking this n naught is equal to minus 1. Then you can write x of n plus 1. So what will happen? Z to the power 1 x of z. So for this we have z transform as x of n plus 1 ಅಂತಂದ್ರೆ z transform z into x of z. X of n minus 1, it will give us the transform z to the power minus 1 x of z. When I say combine together x of n plus 1 plus x of n minus 1, it is nothing but z plus z inverse into x of z. This is what I am asking. Is that clear? So this is the time difference property. Only one z minus x of n minus 1 is taken as an example to prove this, which is same as instead of n minus n naught, we have taken n minus 1. Similarly, we have proved this as we have proved the time shift property. If you look at it, you will get to know that. See here, same thing, n minus n naught is replaced by n is equal to m plus n naught. Similarly, n minus 1 is replaced by n is equal to m plus 1. And finally, we get the desired result, that is z power minus 1 into x of z. So combining x of n and this equation, you will see, combining both, what we get is z transform of this one and z transform again with multiplication of z inverse. So taking x of z as common, or this term as common, we can write 1 minus z inverse, so it will be x of z into this value. Okay, so this is the answer. Is that clear? So if you are not responding, then it will be of no use doing the class. You can respond, you can comment in the text box there, so that it will be interactive. Otherwise, if I go on speaking, I will not be knowing whether you are understanding or not. Yes, I am waiting for the reply. I need to think now that nobody is understanding. Is that correct? Yes. Fine, at least one is ready to accept his understanding. Z power power 1. Yes, that is correct. X of n plus 1. We have to take z to the power plus 1. Correct. So it is straightforward. X of n minus 1. Then we have to take z power minus 1. That is what I have written here, right? Z power 1 is z itself, right? If it is 2, then z power 2. Minus 2, z power minus 2. Simple. Clear? There is another aspect of this that we will discuss later. Okay, but basic idea behind these transforms is the difference property is this one: x of n minus x of n minus 1, you will get 1 minus z inverse into x of z. Now let us solve some of the problems on initial value and final value theorem. So we already know initial value theorem and final value theorem. So based on that, first problem is find the initial value of the signal defined by the z transform. X of z is equal to, let me write this question. X of problem on initial value theorem. Okay, so x of z is given is equal to z into z minus 1 divided by z minus 2 into z minus 3. Okay, for this we need to find out initial value. Initial value of what? Initial value of x of n. Initial value of x of n. Initial value is always occurs at n is equal to 0. X of 0, limit z tends to infinity x of z. This is the initial value equation you can see here. This is the initial value equation. Now, already we know what is x of z, correct? It is given here. Let us put that in this equation. Z into z minus 1 divided by z minus 2 multiplied by z minus 3. These kind of problems you have solved in the limits, right? Limits equation. So what is the answer? I hope you will directly give me the answer before I give the answer here. You need to take z as common, right? So you will get z square 1 minus 1 by z. Yes, any doubt? Divided by z square I will take common, that means 1 minus 2 by z, 1 minus 2 by z multiplied by 1 minus 3 by z. So z square and z square will get cancelled. When I substitute z tends to infinity, this will be let me write it over here, 1 minus 1 by infinity divided by 1 minus 2 by infinity, sorry, became 8, 2 by infinity multiplied by 1 minus 3 divided by infinity. Correct? This is what we get. So answer is 1. Initial value is 1. Why? Because this is 0, this is also 0 and this is also 0. 1 divided by 1, it will be 1. So this is the answer. Okay. Is that clear? Now the second problem what we are going to discuss is, it is on the final value theorem. I hope initial value theorem you have understood how to calculate the initial value of the given signal. Now for final value theorem we have given signal x of z is equal to 2z plus 4 multiplied by 3z plus 5 divided by z plus 2, 4z plus 5, z minus 1. So let me write it. Final value theorem. For this we have given x of z, we need to find out what we need to find out, x of infinity. Final value means x of infinity. So first let me copy down the problem. 2z plus 4, 3z plus 5 divided by z plus 2, 4z plus 5, z minus 1. Z plus 2, 4z plus 5, z minus 1. Okay, this is the x of z given. Okay. Now, what is the final value? Final value of the given function will be x of infinity. Initial value was x of 0. Final value will be x of infinity for this. So here limit is from z tends to 1. Z tends to 1. Z minus 1 x of z. This is the equation. So let us substitute what is x of z given. 2z plus 4, 3z plus 5, z plus 2, 4z plus 5, z minus 1. So z minus 1 and z minus 1 will cancel out. You can now substitute for z is equal to z tends to 1. So it will be 2 into 1 plus 4 multiplied by 3 into 1 plus 5 divided by 1 plus 2 multiplied by 4 plus 5. 6 into 8 divided by 3 into 9. 16 by 9. Is that correct? Yes. That is your final value. It is the final value of the given signal x of n. Is that clear how to calculate final value and initial value? If you have any doubt, please ask now. We can move on to the next problem. Yes. Shall we move on to the next problem?
Yes, sir.
Okay. So here this problem is a easiest problem you can think of here. Given is x of z, z divided by z minus 2 multiplied by z minus 4. Now applying x of infinity, we need to find out final value. So final value, if you want to find, you have to apply this equation, right? So what we'll get is z into z minus 1, z minus 2, z into z minus 1 divided by z minus 2 into z minus 3. Now here we cannot take anything, that is we cannot cancel out this one. We cannot cancel out this. Earlier we have cancelled because in the denominator there was a term z minus 1. Here it is not possible. That's why directly we have to substitute z tends to 1. So when we substitute, then the answer will be 0. So x infinity, our final value will be 0. It is like, what is the final value of this function? If I ask, what you will tell? You will tell that it is going to reach the 0. So this is final value. What is this function's initial value? This might be some a. So this is x of 0 and this is x of infinity. It will be same. Okay, it will be same for infinite time. So here this signal, Q1 signal will reach 0 as final value. Okay, then we have the initial value problem again. Now I hope you are familiar with the equations and how to solve. When it comes to initial value, you have to get the z as common. You need to somehow get z as common so that this term will be in the denominator. So 1 divided by infinity will go to 0. So to get to that form, directly if you substitute z is equal to infinity, so here itself you will get infinity. So no use of calculating only. We have to manipulate the equation such a way that you will get the correct answer. Okay, so z square we can take common. If there were 3 terms, we need to take out z cube as common. Okay, so that we will get the proper answer. So here again the initial value we are going to get is 3 by 2. Remember, this x of 0 is limit z tends to infinity x of z. X of infinity, that is final value, will be limit z tends to 1 z minus 1 x of z. Okay, these are the two very important equations: initial value theorem and final value theorem. Is that clear? Any doubts regarding this? We'll move on to the z transform problems now. Let me know if you have any doubts. So next, we will solve the problems on unit impulse, that is finding out z transform for the unit impulse function. Let me first take x of n is equal to delta n, then we will move on to x of n is equal to delta n minus n naught, delta n plus n naught. Okay, now problems on z transforms. First one, given x of n is equal to delta of n, find out x of z. Okay, this is the first problem. So what is the equation of z transform? X of z is equal to summation n is equal to minus infinity to plus infinity x of n z to the power minus n. Correct? This is equal to n is equal to minus infinity to plus infinity delta of n z power minus n. Correct? I have substituted what is x of n. So what is the nature of this delta of n? Delta of n is equal to 1 when n is equal to 0. So no need to integrate, no need to sum from minus infinity to plus infinity. It is 1 at only this value, and delta of n is equal to 0 elsewhere. Correct? So ಅದಕ್ಕೆ ಏನು ಮಾಡ್ತೀವಿ, directly we can say n is equal to 0. Delta of n is equal to 1 for n is equal to 0 and 0 elsewhere. Therefore, x of z is equal to delta of 0 z power minus 0. So it is delta of 0 is 1, z to the power minus 0 is 1. So x of z is equal to 1. x of z is equal to 1 for what? Delta of n. If you take z transform, then the z transform of this delta of n will be 1. Okay, this is first result. Second one, x of n is equal to delta of n minus n naught. Okay, now again x of z is equal to n is equal to minus infinity to plus infinity x of n z power minus n. This is our equation. Now let us substitute delta of n minus n naught z power minus n. So what is the nature of delta of n minus n naught? N minus n naught, this is equal to 1 when n minus n naught equal to 0. That means n is equal to n naught. When I substitute n is equal to n naught, then delta of 0 will become delta of 0. Correct? It will become delta of 0. Delta of 0 means it exists at only that point. So this is a shifted delta function. So directly we can write it is 1 at only this function, and delta of n minus n naught is equal to 0 elsewhere. Because of this, I can substitute at n minus n naught is equal to 0. This implies n is equal to n naught. Delta of n minus n naught is equal to 1. This implies x of z is equal to 1 into z to the power minus n naught. Okay, so now we can conclude easily that if we have delta of n minus n naught as our input for the z transformer, the z transform of this will be z to the power minus n naught. Z to the power minus n naught. You can see the same results. And I forgot to mention the ROC. For first one, that is delta n function, ROC is all values of z, because it is x of z is equal to 1. No need to go for any z value. You can get only 1. So any value of z, you can get the same answer. So all value of z is the ROC. Similarly here, ROC is z greater than 0. Okay. Next one is delta of n plus n naught. If x of n is this one, let me write it. X of n is equal to, what is x of z? Are you getting? X of n is equal to delta of n plus n naught. Then what is x of z? So we have the equation. We have the equation. It is not visible, right? X of z is equal to summation x of n z power minus n. Now let us substitute delta of n plus n naught z power minus n. Okay, and we know that delta of n plus n naught is equal to 1 only when n plus n naught is equal to 0 or n is equal to minus n naught. Correct? Is equal to 0 elsewhere. So therefore this summation reduces to at n is equal to minus n naught, x of z will be there and it is given by 1 into z to the power minus into minus n naught. I am replacing n by minus n naught. So I will get z power n naught. So clearly you can observe the similar kind of property we have used earlier also. That is x of n minus 1 or x of n plus 1. Correct? So here for the delta function. So if given is delta of n plus n naught, the z transform of this is z power n naught. And here z should be less than infinity because it is positive power. Z should be less than infinity. Earlier z to the power minus n naught was there here. That's why ROC was z greater than 0. It should be greater than 0. If it becomes 0, then it is z to the power minus n naught will be written as z to the power 1 divided by z to the power n naught. If it is 0, 1 by 0 will be infinity. That's why ROC is z greater than 0, whereas here ROC is z less than infinity. Okay, these are the conditions for our delta function, z transform and ROCs. Any doubt regarding these three problems? These are the very straightforward problems. Now let us move on to the next set of important problems, that is the basic unit step function. Find the z transform of unit step function. So let me solve this problem. What we have to find out? We have been given with x of n is equal to u of n. We have to find out what is x of z for this signal. Correct? What is x of z for the given signal? Again, procedure is same. This is our actually it is fourth problem, right? So what is x of z? X of z is summation n is equal to minus infinity to plus infinity x of n z power minus n. So for our signal it is n is equal to minus infinity to plus infinity u of n z power minus n. But u of n is equal to 1 for n greater than or equal to 0 and equal to 0 elsewhere. Correct? Therefore the limits will change as summation n is equal to 0 to infinity 1 multiplied by z to the power minus n. This is our x of z. Okay, we know that we have a standard equation for infinite summation n is equal to 0 to infinity a power n is equal to 1 divided by 1 minus a. Okay, so this is the equation what we have. Based on that, x of z is equal to This implies x of z is equal to 1 divided by 1 minus z inverse here, because this is the exponential n. This is minus 1 into n. So for this we have equation, okay, not for z inverse. That's why directly we can take 1 minus 1 by 1 divided by 1 minus z inverse. So this is 1 minus 1 divided by 1 divided by 1 minus 1 by z. So it will be z divided by z minus 1. So x of z is equal to z divided by z minus 1 for x of n is equal to u of n. U of n. What is the ROC? Z must be greater than 1. Magnitude of z is greater than 1. So how to plot this? We need to draw a z plane. So let me draw it. And what is the pole? If I substitute z is equal to 1, what will happen? 1 divided by 1 minus 1, that is 1 divided by 0, so it will be infinity. So this is the value which is leading us to the infinity. That's why it is called as a pole. Let me introduce it here and I will tell that this is the pole. And where is my 0? If you substitute z is equal to 0, there exists 0. That is x of z will be 0. That's why we have a 0 here. So this is 0 and this is one pole at value 1. Okay. So this is pole and this is 0. Now for taking pole as our reference, we have to draw the circle. This is z plane, imaginary axis of z, real axis of z. Now what is ROC? ROC is greater than z. That's why this is the ROC outside this pole. This is ROC. Okay. This we have seen for alpha n z power minus n also. This particular problem which we had discussed yesterday, day before yesterday. Is that clear? The first problem. This is what we have. Okay. Now the second problem is unit ramp sequence. We can apply the property also, but here it depends on the given marks. Considering say for 6 marks it is given, then you have to apply the Z transform equation and solve. If it is given for 3 marks, two problems will be given, like using properties you have to solve. Then you have to go for, that is multiplication by n is nothing but minus of z d by dz of x of z. This property you can utilize. Okay, that is there. Now it is not specified, that's why we have to follow the procedure, that is using the equation we have to solve. Okay, here again this problem is also simple because we have a standard equation for that. Let us go through what it is. So let us consider second one. Second, or it is fifth one, right? According to us, it is fifth one. X of n is equal to n into u of n. For this, what is x of z? So we have the equation again, x of z is equal to summation x of n z power minus n. Substituting what is x of n? N into u of n z power minus n. So what I can replace u of n as? U of n will change, that is u of n is equal to 1 for n greater than or equal to 0, and it is 0 for n less than 0. That's why any multiplication will lead us to 0. That's why we can have only n greater than or equal to 0. So n is equal to 0 to infinity n into 1 into z to the power minus n. So this is the summation what we are going to get. But for this kind of summation also, we have, let me erase this n into 1, we have a equation. We have a equation that I have shared already. That is summation n is equal to 0 to infinity n into a power n is equal to a divided by 1 minus a whole square. So here I have mentioned it. Okay. That means we have x of z is equal to, this n will leave out only a, right? A to the power n. Here z to the power minus 1. That's why z inverse divided by 1 minus z inverse whole square. This is x of z. No further simplification is required. Okay. And z inverse is less than 1. This is the ROC. Because here a is less than 1. This is the condition for the equation what we are using. You can see here, equation, to use this equation, magnitude of a must be less than 1. So magnitude of a is here for us is z inverse. Z inverse is less than 1 means 1 by z is less than 1. Correct? Or indirectly we are saying z is greater than 1. Okay. So this is x of z for multiplication with the ramp function with u of n. Is that clear? In next class we will solve the other problem, that is negative time unit sequence. This we have already solved. Okay, for minus b to the power n u of minus n minus 1. Go through it, and if you have any doubts you can always contact. Very important problem, that is sine and cosine, that we'll discuss tomorrow. Okay, till now whatever we have discussed, are you able to understand? If you are not following any of the point, please let me know.